In class, we started to take a look at how we can use the idea of direct and inverse proportionality to make quantitative predictions of what's going to happen to the pressure. Now what we want to do is give you a tool that will help you organize your thought process a little bit when you have to solve problems like this. We call it an upscale downscale approach, where you really think about, do you want the number to become bigger or become smaller, and use the appropriate upscaling downscaling technique. For our first example, we're going to look at a butane lighter can. This lighter can is filled with 7 atmospheres of butane gas at 19 degrees Celsius. The 7 atmospheres represents a pressure, so we're going to put that in the initial pressure box. The 19 degrees Celsius represents a temperature, so we'll put the 19 degrees Celsius there. We are then asked to calculate the pressure, so we don't know what the final pressure is going to be, in the can in a storage warehouse if the temperature reaches 37 degrees Celsius. So I'll put that in for my final temperature. We haven't mentioned volume or number of particles here, so we'll just cross those columns out to represent that the number of particles and the volume of the can remain constant throughout the problem. Now we're going to use the direct and inverse proportionality ideas from class to decide if we should upscale or downscale. During this process, the temperature increases from 19 degrees Celsius to 37 degrees Celsius, so our temperature increases. We know from our experience with the various pressure probes and the pressure of gas experiments that if the temperature goes up, we expect the pressure to go up as well. We also have learned that when we work with the temperature, the direct relationship between temperature and pressure is only true if we operate in units of Kelvin for our temperature. So in the first move, we need to take our temperatures and we need to convert them to Kelvin. To get our 19.0 degrees into Kelvin, we have to add the 273.2 that we added in class to move the origin back to 0 again, and we end up with 292.2 Kelvin. So I'm going to replace the Celsius temperature with the Kelvin temperature. I'll add 273.2 to the 37 degrees as well, and I have 310.2 Kelvin. To get a final answer, I'm going to start with the 7 atmospheres of pressure. I want to multiply this by a ratio that will make this number become larger because I expect the pressure to increase when the temperature goes up. My 2 temperature values are right here. When I stack them up to make the 7 atmospheres of pressure get larger, I want to put the bigger value, 310.2, on the top, and the littler value on the bottom, because this ratio in red right here now represents a value that's greater than 1 and will cause the 7 atmospheres of pressure to become greater. When I do the math and round to the appropriate 3 significant figures, I find out that the pressure inside my can is 7.43 atmospheres.